What are quartiles? Quartiles are statistical terms that describe a division of observations into four defined intervals based on the values of the data and how they compare to the entire set of observations. Quartiles divide a set of numbers into four equal parts. Imagine you line up all the numbers in order from smallest to largest. Then the first quartile, Q1, is the number that marks the first 25% of the numbers. The second quartile, Q2, also called the median, is in the middle, splitting the numbers into two halves. The third quartile, Q3, marks the first 75% of the numbers. Calculation of quartiles. Dataset 6, 7, 8, 9, 1, 2, 4, 5. The first step is to arrange the numbers into ascending order 1, 2, 4, 5, 6, 7, 8, 9. The second step is find the median 5 plus 6 bracket over 2 equals to 5.5, and this is the Q2. Third step, if the number of data points is even, we divide the data points into two parts, 1, 2, 4, 5, and 6, 7, 8, 9. Then, median of 1, 2, 4, 5 is 3, and 3 is the Q1, and median of 6, 7, 8, 9 is 7.5, which is Q3. If the number of data points is odd, we directly dismiss the median point and then do step 3 and can directly find the median number. Application of quartiles. For finance, quartiles are used to analyze stock market performance. For instance, the closing prices of a company's stock over a year can be divided into quartiles to understand different performance levels. The top 25% of these prices represent the upper quartile, indicating the higher range of stock prices. Quartiles are also often used in sales and survey data to divide populations into groups. For example, people can use quartile to find the top 25% of incomes in a population. Here comes a question. In a retail store, the sales data for a particular product category is as follows: $100, $150, $200, $250, and $300. Calculate the quartile range for this product category and explain what it signifies in terms of sales performance. Here is the answers. The median is $200. The lower quartile is $125, and the upper quartile is $225. In terms of sales performance, the quartile range signifies the spread or variability of sales within the product category. A larger quartile range suggests a wider dispersion of sales figures, indicating more variability in performance among the products within that category. This range can help identify outliers or products performing exceptionally well or poorly compared to the rest. What is interquartile range? Interquartile range is used in businesses as a marker for their income rates. The IQR is the range between the first and third quartiles, which is Q3 minus Q1. It shows the middle 50% of the data, giving a sense of where most of the numbers lie. Calculation of interquartile range. The dataset is 6, 7, 8, 9, 1, 2, 4, 5. The median of 1, 2, 4, 5 is 3, which is Q1, and median of 6, 7, 8, 9 is 7.5, which is Q3. And 7.5 minus 3 equals to 4.5, and IQR is 4.5. Here are the application of interquartile range. In healthcare, the IQR is used to understand the spread of biological and medical data, such as blood pressure, cholesterol levels, and heart rate. This helps researchers to determine normal or healthy ranges for these variables and identify outliers that might signify a health risk or disease. Furthermore, IQR is commonly used in fields such as finance, economics, and environmental science to detect and remove outliers from datasets. For example, in finance, IQR can be used to identify unusually large or small price movements in the stock market. Here's another question. A manufacturing company collected data on the time taken to complete a specific production process for a sample of its products. The times recorded were 15 minutes, 20 minutes, 22 minutes, 18 minutes, 25 minutes, 21 minutes, 19 minutes, and 24 minutes. Calculate the interquartile range for the production process times. And for the answers, the median is 20.5, the lower quartile, which is Q1, is 18.5, the upper quartile, Q3, is 23, and the IQR is 23 minus 18.5 equals to 4.5.
So I'll be introduced the standard deviation. So standard deviation is not only in the statistic chapter in math, but also we can always see this in business. It's very helpful tool to measure how spread out numbers are in a set. So a small standard deviation means the numbers are close to the average, while a large one means they are more spread out. So the below is the general formula. The small letter of sigma equals to the root of the sigma, the each value in the set minus the mean square over the total numbers in the set. So on the right hand side is the calculation of the standard deviation. So I listed in two steps. So the first step is calculate the mean value. So the above is a data set like from 1 to 9. So first is we can make a sum of the data and over the total number, and we can get the mean is 5. And the second step, we use the general formula. So each value of the data in the set, we can see like y minus 5, the 5 is the mean value, and 2 minus 5 and 3 minus 5 on 2 to 9 minus 5. So it's from beginning from y minus 5 to 9 minus 5, and over the total number is 9. So the standard deviation of this set is 2.58. So the application of using the standard deviation, like weather forecasting. So the standard deviation is used to understand the variation in daily and monthly temperatures in cities. Weather forecasters in cities with a small standard deviation can predict weather more confidently due to less temperature variation, while those in cities with a high standard deviation face greater uncertainty due to more significant temperature fluctuations.